friend of mine. Once you leave my hand, right up until you left, I am but a moment on the ground. Oh, friend of mine, I have no control, got no radio, a line for me to hold you till you're found. I made a prayer, I cut out all the parts, but I'm just a man, filled with hopes and dreams. It's you that's flying free.
Hi, my name is Bob Stalick, and thanks to the generous contribution of Bill Vanderbeek through the National Free Flight Society Foundation, I am pleased to be able to present to you this DVD dealing with the question of E36. E36 is a new event for both the Free Flight Society and AMA. E36 stands for a 36-inch wingspan model that is powered by an electric motor. The rules for the E36 event can be found in the AMA rules book, but essentially it requires a wingspan not to exceed 36 inches, and it allows for a weight of at least 120 grams, and it is to be powered by a 2-cell lithium polymer battery or an equivalent. The flight time for power is 15 seconds for the first 3 flights. The max times are 2 minutes. I am holding a typical E36 model. This happens to be an original, and the components are obvious when you look at the wing and tail and the fuselage, but what's different about it is the motor. This is an electric motor. It has a propeller that is held on with a rubber O-ring. It has a timer that it controls the motor run, and this one has a dethermalizer that is actuated by a viscous timer. Most of the more modern E36 models have a timer for the dethermalizer that is operated from the timer here, and they use a servo to actuate the DT. The other area that is unusual for those of us who are used to flying gas models is this has a battery compartment. The battery is held in this space. It's not included at this time, but it's held in this space, and I have a rubber band to hold it in place. The motor runs are, as I mentioned earlier, 15 seconds for the first 3 flights, and if you max on those 3 flights, then you're allowed to have a fly-off flight, the 4th flight being 10 seconds, and subsequent flights after that being 5 seconds, all for a 2-minute max. So what I'd like to do at this time is to show you the components that are needed in order to build and fly a typical E36 model. I've assembled 3 kits for you that I can show you, and I will, at the end of this demonstration, begin building one and have it built for you as a final project. The heart of the E36 electric free flight model is the motor. And motors come in all different sizes, but the most common one, and one that is sold by several of the providers that I will list with you later, is it's a model 1806, and it costs around $12, and it's rated at 2100 kV, which stands for, the kV stands for basically the RPMs. That's the number of revolutions per volt. And since we're using 7.4 volt batteries, 2-cell light poly batteries, you multiply the 2100 times 7.4, and that's the static RPM, or at least that's the projected RPM. So this motor is very typical, and it's probably the one that's used by most flyers. There are motors that run a little faster, but they weigh quite a bit more. There are motors that run less fast and they are less weight. One of those motors, which I'll show you here, is called the Rimfire 250, and it's made by Electrofly. I bought this at the local hobby shop before I was able to get one of the other models that I was telling you about. This is a 1750 kV motor. However, it weighs 17 grams in contrast to this motor, which weighs around 26 grams. This one happens to be mounted on a wooden or a plywood firewall, so that's how come it looks a little different. Both of these are equipped with a prop saver hub, and as I describe in a little bit, I'll show you how the prop saver hub works. The next item to deal with would be batteries, and batteries come in all different sizes as well. However, we're looking for a 2-cell lithium polymer battery. The standard battery is the 325 milliamp 65C battery. That's this here. And most of the flyers who are flying E36 will use this battery. It is a 25 gram battery, so it's fairly heavy, and if you're looking at a 120 gram weight, using this battery is going to be a penalty. However, most flyers don't build at 120 grams. Most of them are at 150, 180, even as high as 200. So a 25 gram battery is not a big handicap. It produces slightly more power than the smaller milliamp batteries, but as I mentioned, it's a little heavier. This is a 300 milliamp battery. It weighs 21 grams. It produces almost as much power as the 325 milliamp battery, but not as it doesn't hold the charge quite as long. It's a good battery. I use it on one of my models. It weighs 21 grams. This is the battery that I use on the model that I showed you earlier. This is a 250 milligram battery. Excuse me. This is a 250 milliamp hour battery, and I use it on this model all the time, and I get slightly less RPM, but it weighs 17 grams. In my world, building them light is always better than building them heavy. My model, the one I showed you earlier, weighed in when it was completed at 128 grams. It now weighs 132 due to some repairs that I had to do to it. So these are the three batteries. As I mentioned earlier, the 325 milliamp battery is the one that most people fly. It's one that I recommend. And if you decide to use an electronic timer, which we will get to in a few minutes, the electronic timer runs off of these batteries through the electronic speed control, and a lesser battery will not run those timers. So it's important to match your timer, your electronic speed control, and your battery together, or else you'll get some odd times. So the next item to talk about in the list of equipment that you need to fly E36 is a propeller. Propeller, I'll talk about two types of propellers that are in common use. One is a straight blade propeller without a fold. This is made by APC, and it's a Finn electric. This happens to be a 7x4, that is a 7-inch diameter, 4-inch pitch. I've also flown with a 7-inch diameter, 6-inch pitch. The 4 will give you slightly more climb at the beginning of the run. The 6 will give you more climb at the end of the run. I think it's a toss-up which one is the one to use. Now, I mentioned earlier that you need to use these in conjunction with a hub, a fold-away or breakaway hub. This is how this works. Because if you don't use this kind of a hub and the model lands awkwardly, it can break the shaft or bend the shaft of the motor. This, however, is held in place with an O-ring. I'll show that. And it allows the propeller to fold, but without damaging, if you can see that, without damaging the motor shaft. It's held in place firmly, but not solidly. That's true. You need to use this kind of arrangement whenever you're using a propeller that doesn't have a folding blade. On the other hand, we have a propeller with a folding blade. This is a Gropner unit. It's sold by Texas Timers, who also sell the hub. This unit folds up for the power run and back after the power is complete. It's held in place with a couple of set screws, and then it's held onto the shaft by this set screw. The result is that if the model lands with the propeller blades in this position, they will fold and won't damage the motor. The result, of course, is the same as this. It's held in place with the O-ring. This one folds back. The added advantage of this is that these fold in the glide, and they don't provide the same amount of drag that you would get using a blade that does not fold. Next, I want to describe to you the availability of timers. To the best of my knowledge, there are 3 timers being marketed in the U.S. There may be others, but these are the ones I'm aware of. And they come in 2 different styles. One is a mechanical timer that has an electric connector to it. This is produced by Texas Timers, and it's called the Micro E timer. It comes with what the designer calls a pulsar, P-L-S-R, and the pulsar has on the back of it a place for the timer to plug in, as well as a place for the electronic speed control to plug in, and allows this mechanical timer to control the electronics. It's a simple device, but collectively this unit, when put together, I've made a little plywood board for it so that it fits on the side of the airplane. This unit weighs approximately 11 grams complete. If you build one, as I did, out of plywood, you could probably shave off some weight, or you might even end up weighing more. But this is one way to have a timer that runs both the motor, and it will also control a servo that will act as a dethermalizer. You don't need to use the servo, but it's one way you can do it. That's a mechanical timer. There are 2 electronic timers that are available. The benefits of the electronic timers are that they are considerably lighter. This timer, which is the Starlink Flight Tech timer, this timer weighs about 3 grams. It comes already complete with the various pieces of plywood you need to mount it, and it sells for around $35. It has the advantage in that it is very light. It's also pre-programmed, so you can select which program you want to fly it with. For example, in the case of the mechanical timer, you get to set the motor run time by using this scroll. The DT timer is already pre-programmed into the pulsar. In this, there are 9 different presets. There's a 5-second motor run, 10-second motor run, 15-second motor run. There are DT times, as I recall, somewhere in the neighborhood of 5 seconds all the way up to the full 2 minutes, and some combination thereof. in all of that. And you can tell which one you're in by the number of blinks that show up on this little LED light. So that's the Starlink timer. One of the drawbacks with this kind of timer, and the next one I'm going to describe, is they are dependent upon the amount of energy or power that comes from the electronic speed control. And if you use a battery that is slightly run down or has less power, for example, instead of using the 325 battery, you use a 250, these either will not run, or they will not run consistently, or they will give you different times. That's one of the drawbacks of these kinds of timers. However, as I said earlier, they're considerably lighter. This is called the simple timer that is sold by BMJR Models in Florida, and it's developed by Stu Myers. It also has some pre-programming in it, but it's a default. So in this case, the default is 15-second motor run and 2-minute maximum. You can set all of the times other than that simply by pushing the buttons correctly, and it'll give you the signal using the LED light. It's very similar to this one, except you get to set the times on this one. This one is already set for you. This particular timer also is lightweight, weighing in the neighborhood of 3 grams with the frame around it. And as I mentioned earlier, is available from BMJR, and I believe the current cost is $35. So those are the 3 timers that I've set up for you. 2 of them are electronic. One of them is mechanical with an electronic component for the DT system. Okay, the next item we're going to talk about is the electronic speed control. Electronic speed control is sometimes abbreviated to ESC, and I will refer to it as such. Electronic speed control is needed for every E36 model using lithium polymer batteries with 2 cells, as it converts direct current into alternating current for the types of motors that we're using. This pretty simple device. It has 3 wires here. These 3 connect up to the motor. Interestingly enough, you don't know which ones to connect until you plug them all together and you find out the motor's running backwards, not running at all, or running forward. So you just simply move them around until the motor runs in the correct direction. The second is a battery connector. So as I mentioned earlier, you're using probably the 325 milliamp battery. That connects here. And the final piece is this connector, which is the one that connects up to the timer and therefore provides power. The 10 ampere or 10 amp unit, which is what I'm holding here, is fairly standard. Most of the motors draw about as much as 10 amps, some a little bit more current, and this is adequate for the task. If you are using stronger batteries, or if you are flying some other event besides E36, you probably want to go to a heavier ESC. Also, I should point out that the larger the ESC, usually the more they weigh. This one weighs 11 grams as you see it. The one I have in the model that I demonstrated earlier is a 6 amp, and it weighs 7 grams, so there's a savings there of several grams. A lot of people use a 12 amp, and they weigh a couple of grams more than this one. But this is pretty standard, and we got this from Texas Timers. So we have gone through all of the components that are needed, other than the kit, of course, or the model itself. All the components that are needed in order to make an electric model run. So what I'm going to do now is I'm going to plug all these pieces together. I'm going to plug the timer into the ESC, I'm going to plug the battery into the ESC, I'm going to plug the motor into the ESC, so that you can see all the components all spread out. And then I'll press the button, the start button, and you'll see everything work. Okay, so this is the back of the timer. Plug the ESC in. where it says, like that. See how that fits in there like that? Then we do the same thing with the battery. There. So there's the battery. There's the timer. Now we plug in the motor. Okay, it's all plugged together. I'll hold up the motor like this, and you'll notice that there's this button here that I push. When I push that, it should start. And it did. Of course, it was going backwards, which means that I need to change a couple of these plugs. Now, since they're not marked, you don't know which one is you're doing it with, but we'll try it again. Ready? There we go. I'm going to show you 3 kits that are available on the market. There may be more. There may be others that I'm not aware of. And there certainly are plans out there for models that you can look up and build from scratch if you're so inclined. The 3 kits that I have selected are very much available online or from retailers. The first one, and the one that's been around probably the longest, is called the Sparks. And the Sparks was designed when the E36 rules were not as advanced as they are now. It's an older design by my friend Rex Hinson. It's won its share of contests both at the Nats and at local events. The next kit I'm going to show you is called the Mutt. And this is from a new kit maker on the block. The Mutt is also a full kit. It is laser cut. You can see from, I think you can see from this picture a little bit what it looks like. It's all balsa, and it comes with all the parts you need in order to build it, short of covering, of course. The kit that we're going to build for this feature is called the E-Pearl 202, and it's designed and produced by Don DeLoach.
Well, this is the origin of E36. We were flying it in Flying Aces as a fun event, old-time gas, and then we changed it into electric or CO2 or whatever. And that was kind of the basis for the rules that I submitted to NIFIS years ago. And we finally settled on nothing more than 36 inches and using a brushless motor. But the difference was with the NIFIS rules, we set the time for about a 20-second motor run, and then 2-minute maxes until somebody got more than that. And then we cut the flight, the electric run down to 10 seconds and then 5 seconds. And the idea was to keep it a small field event and very basic. 4 nickel cadmium cells to power it, and a minimum weight of 150 grams. And that actually was flyable for a 2-minute flight, and it worked pretty well as a small field event.
So you are the originator of the event? It was your original idea?
The original set of rules were drawn up with my concept of what it should be.
How has E36 evolved since your original concept?
Well, we have a whole bunch of changes. Let me show you something that's more up to date. You can see here we have a brushless motor and folding prop blades, which are much better than what I used originally. And we also are using a LiPo battery to power this, and the difference in the performance is considerable. The first 3 flights now are 15-second motor run, as opposed to the other one, which was 20 seconds. And we have kept the reduction in motor run time to 10 seconds for the first fly-off flight, and then 5 seconds for all of the fly-off flights after that. And things have gotten pretty good because the guys are now getting 10 and 12 flights in fly-off times. So the new electronics has made quite a difference in what's going on with the event.
Good morning, guys. Who am I talking to today?
Linda Powell,
And who are you, sir?
Chuck Powell, husband.
Where are you guys from?
Wichita, Kansas.
And what model are you flying here today?
An E36.
E36. And Linda, how long have you been flying E36?
About a year right now. Yeah, about right at a year.
And I heard something amazing happened with you a while back ago. Can you tell everybody what happened?
Yes, I made a record with her out in Lost Hills with 8 Maxes.
8 Maxes?
Yes.
What model are you flying?
I call her the Pearl. She's built by Don DeLoach, or designed by Don DeLoach.
Uh-huh.
And I'm sorry I don't remember names of planes and Pacifics. I always, have 202. Thank you. And like I said, I'm still learning a lot in flying. The Pearl was one of the first ones I saw because I like the electric engine. She's a clean machine. I don't have to mess with much but just the batteries and put my tracker on. And she really wants to get out of your hand. She wants to fly. That's what I loved about her, is the feel of, she wants to get out of your hand. She wants to get to the air.
Gotcha. So you know what? This might be just a good time to go get some footage of you putting her up in the air.
Oh, that'd be awesome.
All right, let's go do it.
Okay, let's go. Let's go play and have fun.
All right, you got it. Let's do it.
David Seacrest.
Where are you from, David?
I'm from Bristol, Indiana.
And what event are you flying here today?
This is E36 electric.
Okay, and tell me about your model.
This is a mini Pearl fuselage, and it has a Maverick wing on it. I've got a Cobra motor. It's a 220334, a 2300 kV motor. I'm running a Turnigy battery on it. It's a 350 with 130C discharge rate. I've got a Will Hubin timer on it. It's an extremely light timer. It has a separate programming box. It's really user-friendly. The box is LED readout. No instructions needed. It just spells everything out on the LED. It's really, really handy to use. It's my second year flying E36.
What's the speed controller on there?
The speed controller is probably a Turnigy Plus 12. It just has a Hobby King servo on it. It's probably 3.5, 4 grams.
And what's the model weigh all up?
It's about 145.
Nice weight. Nice weight.
It's not bad.
And what's the lure of E36?
You can fly a power model without getting your hands greasy. You know the motor's going to start. It does the same thing every time. It's just so pleasant. There's no noise, there's no smell, and you can fly power that way.
Gotcha. And what design is the model?
This is just a reduced Maverick. And instead of using a square fuselage, it has a thin fuselage like a mini Pearl. That's all it is, a Maverick. It's reduced, I think it's 82% of a full-size Maverick.
Cool.
I have added a sub rudder to it. It never flew right without that.
I understand.
I spent a whole season trying to get it to fly. And one day I decided to increase the rudder size, and it miraculously did what I wanted it to do then.
Excellent.
Yeah. So,
And you're going to continue. How many more flights do you have today?
well, I'm going to try to make the 5-second one next, but I need some help. You've got to be in lift.
I understand.
You've got to have some help in 5 seconds.
Okay.
Good. Turn.
Morning, sir. Who am I talking to?
This is Dick Koval,
Where are you from, Dick?
Anderson, Indiana.
And what event are you flying today?
E36.
And tell me a little bit about your model.
Well, this is obviously a satellite type, and it actually is a half A 226 that's kind of been puffed up and cored, and it ends up being about the same area as a standard half A satellite with a 36-inch wingspan. And I find that it works quite well. The wings, you can make the wings stronger, and I've had real good luck with it.
What motor are you using on this?
This is an RC Timer motor. RC Timer is an outfit that buys parts, mostly Turniggy parts, and winds the coils and puts magnets in it, and they tend to put a little bigger magnet in it than Turniggy, so you get a little more output. He sells on the internet under the trade name RC Timer. It's just an entrepreneur in China.
And speaking of timers, what's the timer that you're using for this model?
I beg your pardon?
What timer are you using for this model?
Oh, this is my own timer. It's unfortunately, I've got it behind a faceplate in order to protect it from moisture, but it's a timer, a smaller timer I made specifically for E36, and it actually carries all your flight schedules inside, and you just press a button and count some flashes to select a flight time and a DT. I find it works quite well.
Hello, my name is Mark Freeland. I am the owner, designer, builder, dog's body of Retro RC. I started a small home-based business in 2008 designing model aircraft kits and laser cutting them and selling them on the internet.
What kind of kits do you sell?
Well, I do a lot of radio control kits. Living in Michigan, our weather is not particularly good, and most of the flying there is radio control. There's not many places you can fly free flight. But I also do a large number of free flight kits, which is actually the major part of my business. Everything from free flight gliders, small gliders for kids to play with, to my biggest one is an E36 contest model.
So tell me some of the particulars about your E36.
Okay, well, this particular one that we have here, I'm using the N1806 2500 kV motor that's available from Hobby King. It's a relatively cheap motor, under $10, plus postage from China. The battery that I use is a 300 milliamp hour Nanotech, and this year they came out with a new battery that has a burst discharge rating of 90C. So that's what I'm currently using. Last year I flew it with a 70C. The timer that I'm using is one of Will Cuban's timers. Great little timer. He's designed it specifically for F1Q events, the FAI event where you have multiple positions for your DT servo, so you can have a variable instance tail. Obviously for this contest you can't use that, it's purely fixed surfaces, but I just use the motor timer portion and then the DT portion of the timer. But it's a real neat little timer, and basically the pit that goes in the aircraft only costs about $10, which makes it ideal. And then we have a small 3.7 gram servo that I use for the DT. The ESC is up in the Pylon, and you can use either a 10 or a 12 amp. It doesn't really make much difference. And I prefer to fly this aircraft on a fixed pitch prop, although a lot of the other people that use this motor have been using the Greipner 7.5 inch folding prop. I find that the motor much prefers a lower diameter fixed prop, and you don't have to mess around with hanging blades, etc., with the really slow glide that the aircraft has.
Okay, here goes. Need some trim work. I've got another.
Now you've had an opportunity to see how E36 models fly. My activity here is to show you how to build one. And the model I've chosen is Don DeLoach's E-Pearl 202, and we will use his kit as a starting point for this discussion. What I'm going to do first is to take the parts which have been laser cut and punch them out. The ribs, like that. It just, I think that Bob Holman did the work on this from the laser point of view, and he did a super job. All these little gussets, we'll need to set them aside so they don't get lost, but they're important. I think I've got them all. The kit comes with laser cut plywood pieces, and these are wonderfully done, but they have little gizmos here, I don't know what else to call them, that hold it in place. And so the consequence of that is these turn out very dark, and they need to be, if they can't be punched out, you need to use a knife to get them out. What I'm doing here is I have gone to my local hobby shop and I've picked up the long wood that you need for this model, because it doesn't come with anything but the punched out parts that I showed you earlier. So you have to pick up wing spar stock, stabs, leading edge, trailing edge, and so forth. So I've done all that, and I'm now going through this pile of good stuff to make sure I've got the right pieces to build this model. So what I'm doing is I'm going to cut the spar stock to size, and be ready to build the stabilizer. The stabilizer and the wing are built very similarly, with the exception that the wing, of course, has dihedral and polyhedral in it. But the construction is identical. So I'm going to build the stabilizer, and then later on I'll build the wing. So what I'm going to do now is to notch the trailing edge. If you look at the plans, you notice that the ribs inset into the trailing edge very slightly. That helps the glue joint, keeps the trailing edge from warping. I'm going to show you how I do that using a pencil and a cutting pad plus my X-Acto knife. So here we go. So now I have the trailing edge glued in place, pinned in place. I have notched it so that the ribs can fit in as they're supposed to. The next step is to pin the leading edge in place and the spar on the bottom. So we're going to do the leading edge and the bottom spar next. So after we have the ribs in the proper place, glued in place, you'll notice that the plans call for false ribs. These are the little half ribs that fit on the front of the wing, or in this case the stabilizer. And we also have these trailing edge diagonal ribs which fit on the back. They keep the stabilizer from warping. So I'm going to install both those trailing edge diagonal ribs and the leading edge false ribs next. And at the same time, you'll notice that this calls for some gussets to be put. These are little triangular gussets that beef up either the leading edge or the trailing edge where the joints are critical. So I'm going to do all of those in this next demonstration. I've been sanding a bevel on the edge of these diagonal ribs so that they have a better glue surface. I don't know that it's really needed, but I like to have a nice fit, and that helps when it glues up against there. The other thing is I trim off the back end to make it fit in the slot, and I usually trim it off at an angle so that the angle fits the angle that's made between the rib and the trailing edge. The other thing is, sometimes if you're not really careful, it's possible to glue these ribs in upside down so that the curved part is on the bottom, and you don't want to do that. So if at all possible, sort them out so that the curved part is always on the top. Okay? So I mentioned earlier that I do most of my construction with SIG bond, but I also use CYA adhesive. This is ZAP, and here's how I'm going to use it on this stabilizer. I'm going to glue the turbulator spar in place, and also the top spar using this. I've fitted both of those pieces onto the stabilizer, and all I have to do is hit it with a drop of this stuff and it'll be done. I have removed the stabilizer from the plan, and I have sanded off the edges so that they're smooth. My next step is to glue on the tips. The tip on either side is just a flat plate, and for this purpose I'm going to use this SIG bond, and these are pin curl clamps. You can buy them in the local drugstore. I think they're used, women use these for pin curls. I'm assuming somebody still does pin curls, but you can buy these clamps. What I like about them is that they have a little bit of pressure, but not so much that they crush the balsa wood. And they're good for anything up to about 3/16 of an inch. I use them on a lot of modeling applications. So that's what we're going to do next. So we'll do the tip. One of the things that happens with the stabilizer, and also with the wing to a lesser degree, is that the leading edge needs to be shaped. So as you look at the stabilizer, there should be a steady and graceful curve that runs across the top of the airfoil here, and this 1/8 inch square leading edge needs to be shaped so that it flows into a nice rounded edge. And I usually, using some sandpaper, will also shape the bottom part of that edge so that it's gradually rounded off the top and the bottom. Looking at the plans, you'll be able to see what the airfoil is supposed to look like. The other thing I do is, it's always the case that the ribs don't always meet up with the spars like they're supposed to. So there's a little bit of balsa that's sticking out. And as a consequence, very lightly go over the entire leading edge. I'm using some 220 sandpaper on a sanding block, and sand off any of the rough edges, the little lumps and bumps that stick out, so that that's good and smooth. Do the same thing on the bottom. I do it at with this angle to it. This is pretty smooth. It came out better than I anticipated. So once you get those lumps and bumps out of it, you're ready to cover. This is a pretty stiff structure, and I'm convinced that it's going to be fine for covering with plastic film. In order to speed things up, I've actually already glued the tips onto the main panels of the wing, but what I'm going to show you is how we glue the main panel together. It's simply a repetition of what we did with the wing tips. So we've got those two panels we're going to glue together. I'm going to go through this with you and show you how that's done. I have these are the dihedral blocks. They're cut to size. This is 7/8 of an inch, and they're pinned in place right underneath the polyhedral joint. There's one on the trailing edge and one on the leading edge. The same is true on the other wing tip. So what I'm going to do is I'm going to apply the glue. Once again, I'm using Sig Bond, and I'm going to pin the parts together. Now before the spars, which I've glued together, dry, I want to put in the rib, that's the center section rib. If you look at the plans of this model, you'll notice that it's actually two 1/16 inch ribs glued together. And I've cut it to length so it fits right in the slot that's available. Once I put it in place, I'm going to pin the spars in place so that there is enough room for them to maneuver. And I've cut an additional slot in the main spar location so that I can slip in the 1/16 inch dihedral brace that is provided as part of the kit. I'm going to show you how I do the finishing up on the wing structure. I'm sure there are different ways to do this, but I like to pin everything down to the plan, make sure it has a chance to set and dry. So what I'm going to do is I'm going to unpin everything, and I'm going to put the wing flat on the plan and glue in the diagonal ribs and all the other parts that need to be glued in before I pick it up and do the underside with the gusset. The step I'm about to describe, I've done some of the work on it already, is to, while the wing is pinned down in this condition, is to glue in the turbulator spars. Those are the two spars on top in front of the main spars. But the second thing I think it's important, because this is otherwise would be a pretty flimsy wing, is that you need to glue in the webs between the two main spars. These webs come in as part of the kit, and they're amazingly the right size, at least they were for me. I sanded them down just slightly to get rid of the brown spots and also to make sure that they fit exactly. But I've cut them both to shape. I'm going to install one set close to the center section, but they go all the way out to the next to the last panel out toward the tip. It's important that all of these spar webs are glued in, and they're glued in well. I use tight bond because it fills up, or Sig Bond in this case, because it fills up any gaps. One of the things you need to have is some 16th inch balsa wood, preferably sea grain, and you need to make a fin. Now the fin size and everything is shown directly on the plan. This one has been cut out of 1/16 inch sea grain balsa wood. The general direction for the top part runs up and down, and the general direction for the bottom part, or the subfin, runs lengthwise here. This will be glued onto the boom when the time comes. So this is the fin, 1/16 inch balsa wood with a 1/16 inch top cap, and I put some basswood on the leading edge to make it stronger. The other thing you'll need is on top of the pylon, you'll need a wing mount. This wing mount is made out of 32nd balsa sheet glued together, and it's got a 1/16 by 1/8 inch spruce. The plans call for hard balsa, but spruce, in my opinion, is better, on either side to match the dihedral angle of the wing as it sets on top of that. And the other part that you need to make is the pylon. The pylon is actually just 1/16 inch balsa wood. You can use the same balsa wood you used for the fin. I chose to use it was called an A-grain balsa wood, but it almost doesn't matter. Fairly lightweight. And what I've done is you can see this. This is the left side of the pylon. This hole you see here has been reinforced with some plywood. And this is the hole through which the electrical wires come out and join up with the motor and with the battery. The battery is outside the model. It's hanging underneath on a piece by using a piece of Velcro. And on this model, the pylon is a very important piece of equipment because everything fits inside the pylon. The electronic speed control fits in there, the timer fits in there, and the DT system also fits in there. And it's not a very large space. So what comes in the kit is the teardrop shaped former that forms the bottom and the top of the pylon. And the rest of it you have to construct yourself out of 1/16 inch balsa sheet, which is not provided in the kit. What's important to do when you glue the sheets together is to recognize that there's a front and a back. The front, or leading edge, has more incidence, or it's taller, if you will, than the back by approximately 3/32 of an inch. Take a good look at the plans and measure very carefully when you glue those pieces together and cut them out. So what I'm going to show you today is the pylon. I've glued one side to the formers, and I've actually installed the electronic speed control so you can see how it fits. It's the part that when you glue the second side, the back side if you will, onto the pylon, it's encased inside the pylon and it is not easily removed without disassembling the pylon. So let me show you what I've done. This is the face of the pylon, and here is the opening for the wires. These wires are for the motor. This wire comes back, and this will be for the battery. This goes to the timer. On the opposite side of you can see the electronic speed control. It's taped in place with masking tape. I've also installed a bulkhead that runs vertically in the pylon. I did not have 1/8 inch balsa, 1/8 inch dowel for the wing mount. I made this out of 3/32 inch aluminum tubing, which has a 1/16 aluminum tubing inside of it, so it's good and stiff. What we're going to do now is to put the other side of the pylon in place. The fuselage on this model is actually a carbon fiber tube. I purchased this tube from Stan Budenbaum. It's one of the items that is recommended in the plan, but is not included as part of the kit. The motor is mounted on the front of the motor tube like this, and it says to fill in with block balsa. So what I have done is I have installed the block balsa first. I will complete the firewall, glue it to the front end, and then we'll shape the block balsa so that it's round and matches the firewall. So as I look at the plans, I'll fold this back here and take a look at the plans. I'll see that the leading edge of the wing is right about there. I'll make that mark on the plan. That shows it to be about 7/8 of an inch behind the firewall. There's enough taper here that the leading edge being here, I've got this distance to work with where I install it. So 1.5 inches behind the firewall puts this right, put the pylon right there. As it sets up, it would be right about there. Now that's going to make shaping the firewall a little difficult. So I think what I'll do, rather than install the pylon at this point, is I'm going to install the firewall on this so that I can shape it before I put the pylon in place. The kit comes with 2 discs for the firewall. They're each 1/16 of an inch plywood. One of them has a slot in it and the other one does not. The kit also recommends that you bend a piece of wire. This is 047 wire, and I've bent it to shape. It has a leg in it, and it also has a little wire loop to help absorb the weight when the model dethermalizes. Now, because there are only 2 discs that came with this, I actually cut a 3rd disc because I like to make a sandwich of these products. So there will be a front, a middle, and a back. And I'll epoxy all these 3 pieces of plywood together, and that will be the firewall. The motor comes with holes drilled in the right spot. However, they're too small for a 256 bolt. Not by much, but a little bit. So I've drilled mine out so that I can mount it with a 256 bolt. It's possible, and Don recommends this as part of the plan, that you just fasten the motor on with wood screws. I'm a little bit skeptical about that. I'm sure it works fine, but in my case I'd like it to be a little bit more permanent, a little more exact. So I use 256 bolts. Prepare the firewall for drilling so I can put in my 256 bolts. And I just match the motor mount up against the firewall. Try to avoid the wires so that I don't drill a hole in the wrong spot. There's no up or down on an electric motor, so it's not like a gas engine where you want the cylinder probably facing up. So right now I've made 3 spots. I'm going to drill these out large enough to install a piece of yellow nylon tubing, which I will use as my 256 nuts. So the next step is to cut some nylon tubing to length and insert it in the slots that I've just drilled, the holes I've just drilled in the firewall. And these little pieces of nylon tubing will act as a blind nut for the motor mount. Those are the 3 pieces of nylon tubing. I cut them slightly oversized and pushed them through the holes that I just drilled. I'll hold them in place with some jet, which seems to do the trick. Usually on occasion I've had to use micro balloons in order to hold them, but by and large that's not been an issue. After the jet is cured, then I'll take my X-Acto knife and I'll trim them flush with the firewall. Then I'll tap them with a 256 tap, and that'll allow me to install the motor mount. What we're going to do now is we're going to fasten the motor mount onto the firewall, make sure everything lines up, and all of this is in preparation for gluing the firewall onto the front of the model. If you look at the plan, you'll notice that Don says it uses 0 down thrust and about 3 degrees left thrust. So I'm going to sand in a little bit of left thrust here before I install the firewall. I can estimate what that's going to be, which is what I'm going to do. You may want to measure it more accurately than that. That appears to be a couple of degrees. I'm going to install the firewall Make sure that the skid is facing down. So there's a little bit of method in this madness. I'm going to hold the firewall in place using rubber bands. I'll show you how I do that. Smear plenty of epoxy on there. Make sure I've got it lined up with my left thrust in place. Hold it. Grab the rubber band or rubber bands. Wrap it around in that fashion. Looks like I need to reset it here a little bit. And I'll do another one on this side. So now I've got my landing gear sticking, in this case, straight up, but it's going to be sticking straight down because it's actually in this shape. Firewall is centered on that, on the balsa blocks. Now we just let it cure. So I've got the firewall on in place. It's been put on with epoxy, and now I'm going to shape the pod so that it's basically the same shape as the firewall. I'll taper it into the boom, and then we'll go ahead and install the pylon. Underneath the pylon I put a rail. If you can see, I drew a center line. That black line is the center. Okay. There's a center line runs down there. And on either side of it is a 1/16 inch square rail that I've sanded. And that helps guide the center of the pylon to the fuselage. It helps me center it. So the next thing I do is I use the tape, make sure it's lined up, and tape it in place. Okay, it's lined up. Now it's just a matter of letting it cure. This is 1/16 inch fin. Since the pylon is pretty much cured, it determines what's vertical, and so for the fin I have to make sure that I'm mounting it so that it's equivalent to the pylon. When I was constructing the stabilizer, the one thing I mentioned was that the stabilizer hook that comes with the kit is plywood, and there's no apparent slot left for it in the ribs. So I decided not to use that plywood hook. Instead, I said I would use a paper clip that I would bend to shape. So what I have done here is I've installed that paper clip. It has a hook on it, and there's a leg that sticks down into the balsa wood rib. It's held in place with hot stuff, CYA, and micro balloons. It's very sturdy, won't pull out under normal use, I should say. Then the second thing I did, which is called for in the plans, is to install a 1/32 plywood. This is a triangle. In the plans it shows a circle. I do better cutting triangles than I do circles. And it's got an adjustment screw in it. This adjustment screw allows you to change the incidence angles on the model as you trim it out. It also has a hole for the dethermalizer line to pass through. So this, if you can see it here, this is the hole for the thermalizer line. It will come out here, and it'll, because I'll tie a loop in it, it'll loop underneath here, and it'll be held in place with the rubber band. I've covered the pylon with Japanese tissue. I've put my name and address and phone number on a tag, and I've fastened that to the side of the pylon. I masked this area of the pod where the motor fits, and I sprayed it with the Design Master red paint. This is available at Michael's craft store and probably other places as well. I've covered the fin with Japanese tissue, and of course no model is complete without having a decal of the National Free Flight Society on the fin or somewhere else on the model. So I've done that. Now, as you can see from this side, the timer has been mounted. I used the timer that I purchased from BMJR, and it's called the Stone Age timer. It's a very simple device. Now, in order to make it easier to handle, I also put an on-off switch. The on-off switch allows me to switch the battery on or off. That saves the battery, which is important, and it allows me to be more flexible in how I handle the model. So here we go. We'll put the motor on. I'm going to put it on so that the wires are on this side. They mount up close to these wires here. These are the wires that hook up to the motor. Use a little hex driver to tighten up the Allen screws. Hold the motor in place. Now that's set. Next thing is putting these wires together with the wires that come from the speed control. The battery is fastened to the Velcro, which is fastened to the bottom of the airplane. I've hooked up the battery to this battery lead that comes from the electronic speed control. If I need to adjust my weight because of the center of gravity location, I can move the battery slightly further aft, or I can move it slightly further forward. Doesn't much matter. And the Velcro gives me enough leeway that once I've mounted it, I need to make sure that for future occasions I mount it in the same location, or else I'll upset the center of gravity. Back in the on position. It's ready to go. If I'm ready to go, we'll press the button. Let go. That's the right position. The next thing I need to do, I'm going to turn the switch off. I'm going to leave things hooked up. I'm going to prepare the wing to be mounted on the fuselage. Okay, the wing is not quite finished. I have the numbers to put on. I'll show you how I do that in a few minutes. I also have the keys to put on, and the keys are the devices that allow the wing to be put in the same spot on the platform time after time after time. My keys I make out of dowel. This is 3/16 inch dowel. They are approximately 1/4 of an inch long, and I take a piece of 3/16 inch dowel and I split it in half, and they will go underneath the wing, where the wing butts up against the wing platform. So in this step we rubber band the wing in position. Make sure that it's lined up equally. Okay, so what I'm going to do here is I'm going to put a drop of, this is gap filling Zap, on the dowel, the split part dowel. So let that set. I'll do the other side. Okay, this is the completed model. It's ready to be test glided. I've balanced it, and it balances where it shows to balance on the plans. At this point in time, the next thing to do is to go out and do some test gliding, see how it flies. In this video, you'll see a number of people who have models similar to this, and they have trimmed them out and they are flying them. So I hope you enjoy flying E36. It's a great event. It's a good event for people who are just getting into it, because there's no muss or fuss over with engines. The only thing you have to do is make sure your batteries are charged. You can usually get 2 or 3 good flights out of one charge, but you need to keep them charged. There you go. That's the E-Pearl 202, designed by Don DeLoach. Hope you enjoy flying yours as much as I'm going to enjoy flying mine.
Yeah, oh friend of mine, once you leave my hand, right up until you left, I am but a moment on the ground. Oh friend of mine, I have no control, got no radio, a line for me to hold you till you're found. I made a prayer, I cut out all the parts, but I'm just a man filled with hopes and dreams. It's you that's flying free. Oh friend of mine, fashioned with my hand, riding on the wind is all you understand. It's a secret I will tell. I can finally shout out loud, you're giving me the chance to dance among the clouds. I made a plan, I cut out all the parts, but I'm just a man filled with hopes and dreams. It's you that's flying